Okay, one of the review problems that people have been asking me about was the one dealing with the rectangular field. So you're given that you have a rectangular field enclosed by 1,000 feet of fence. You're to write a function for the area if x represents the width of the field. And the question also states that your function should be only in terms of the width x. And then the second part of the question asks you to find the domain. So we'll actually work through all of those. So the first part here that we want to take out of the question statement is that we know that we're enclosed by 1,000 feet of fence and that we have a width that we're going to let be x. So let's take a look at that. So we have the width of the rectangle is x, the length is y, and we know that if we add up all of the sides, which is a perimeter, 2x plus 2y is equal to 1,000. Or x plus y is equal to 500. We get that by dividing by 2. So we have a relationship now between the width x and the length y. So we know that x plus y is equal to 500. And ultimately we're looking for the area of the function. And so we know that the area of a rectangle is length times width, so the area is equal to x times y. But the problem states that we need to find the area in terms of the width only. And you see here that our area now is in terms of the width and the length y. So we'll use this equation, the x plus y equals 500, to solve for y, and then we can replace the y's because it will be in terms of x. So if we just rearrange, subtracting x from both sides, we get that y is equal to 500 minus x. So that means that the length of the rectangle, y, is equal to 500 minus x. So I can use that to rewrite my area. So the area is equal to the width, which is x, times the length, which is 500, minus x. And let me just do this for notational purposes. I'm going to rewrite that and emphasize the fact that that function now is a is a function of x alone, because we replace the y with the 500 minus x. So this part right here is just the y from above. And if we multiply that out, if we want to, then we see that a of x is equal to 500x minus x squared. All right, so we've taken care of the first part of the problem. But now let's look at that picture again. So we see here that because what we're going to do now, we've actually found this area. That's what we were looking for. Now we need to find the domain of the function. So what does x represent? Well, x represents the width, right? It's this distance over here. And we know that if we're looking at a rectangle, there's no way that the width of the function can be any smaller than 0. So from that picture, and I'll just recreate it over here. And that's x, and that's y. We know that x has got to be greater than or equal to 0, because it's not possible physically for the width of a rectangle or the yard or field to be less than 0. And then we had another relationship. I'm just going to stick it up here in red so we can remember that. And that was y was equal to 500 minus x. Now that represented the width. And so 500 minus x as well cannot be any smaller than 0. So we know that 500 minus x must be greater than or equal to 0. And if we just rearrange, that will give us that x must be less than or equal to 500. Because if x is equal to 500, then the length is 0. If x is bigger than 500, then this length actually becomes negative, and we need to avoid that. So what have we gotten from those two pieces? Well, what we've gotten here is that x has to be greater than 0, and x has to be less than or equal to 500. So x then is between 0 and 500. So the domain of our function a is equal to x such that 0 is less than or equal to x, which is less than or equal to 500. And we saw from our work before that the area is a function of x, and it's given by 500x minus x squared.